This is ELC131, Circuit Analysis 1, and the topic is electrical quantities. Now, the electrical quantities that we'll discuss in this presentation are electric charge, voltage, electric current, electrical resistance, and electrical conductance. As we progress this semester, we'll add additional quantities to this list, such as inductance, capacitance, and impedance and reactance. Now, the first quantity to define is electric charge. Electric charge is the fundamental quantity of electricity. The symbol for charge is the letter Q. The unit of measure is the coulomb. The unit symbol is the capital letter C. 1 coulomb is defined as the presence or absence of 6.24 times 10 to the 18th power electrons. Now, when we progress into electronic devices, we'll also discuss or want to talk about the charge associated with one electron, which is 1.6 times 10 to the negative 19th coulombs. Now, appreciate why we have to use the approximately equal to symbol here, because it's impossible for us to have this precise of a number of electrons, 6.24 times 10 to the 18th. So this is an approximation based upon the definition of what a coulomb is. Now, the next quantity to define is voltage. Voltage is the potential difference across 2 points. And this potential difference can either be a source of energy or the drop of energy, the drop in energy of an electron when it passes through a resistive element. The symbol for voltage is the letter V. We use the capital letter V for a steady state voltage and the lowercase v to describe an instantaneous level of voltage. The unit of measure for voltage is the volt, and the unit symbol is also the capital letter V. Now, you may see some text, you may talk to some technicians or engineers that use the capital letter E for the unit symbol for voltage. However, the capital letter E is now reserved as the unit symbol for electric field strength intensity, and the capital letter V is used as the unit symbol for voltage, regardless of whether it's a source of energy or a drop in energy. Now, mathematically, voltage equals energy over charge. 1 volt of potential difference exists across 2 points when 1 joule of energy is consumed across those 2 points and 1 coulomb of charge is separated across those 2 points. The next electrical quantity is electric current. Electric current is simply the flow of electrons. The symbol for current is the letter I. Again, the capital letter I for a steady state current, or lowercase I for an instantaneous value of current. The unit of measure is the ampere. We quite commonly simply state this as amps. The unit symbol is the capital letter A. Mathematically, current equals charge over time. 1 ampere of current flows between 2 points when 1 coulomb of charge exists. 1 ampere of current flows when 1 coulomb of charge pass a point in 1 second. The next quantity is electrical resistance. Resistance is the opposition to current flow. The symbol for resistance is the capital letter R. The unit of measure is the ohm, and the unit symbol is the Greek letter omega. Mathematically, R equals V over I. Resistance equals voltage over current. 1 ohm of resistance exists between 2 points if 1 volt of potential difference is across those 2 points and 1 amp of current flows through those 2 points. And the last quantity to define is electrical conductance. Conductance is the ability for current to flow. The symbol for conductance is the capital letter G. The unit of measure is the Siemen, and the unit symbol is the capital letter S. Remember, lowercase s is reserved as the unit symbol for the second. Mathematically, conductance is the reciprocal of resistance, which can also be defined as current over voltage. 1 Siemen of conductance exists between 2 points when 1 ohm of resistance exists between those 2 points. Now, keep in mind that conductance defines or describes how easy it is for current to flow. Resistance describes how hard it is for current to flow. So these two quantities, resistance and conductance, are conceptually opposite, and they're also mathematically opposites. So the electrical quantities that you need to be able to list and define are electric charge, symbolized with the letter Q, measured in coulombs, the unit symbol, the capital letter C, voltage, symbolized with the letter V, measured in volts, the unit symbol is the capital letter V, electric current, symbolized with the letter I, measured in amperes, the unit symbol is the capital letter A, electrical resistance, symbolized with the capital letter R, measured in ohms, the unit symbol is the Greek letter omega, electrical conductance, symbolized with the capital letter G, measured in Siemens, the unit symbol is the capital letter S.